total internal reflection can only occur when light travels what, right? Or in which of these, right? So remember that total internal reflection, let's say we have water here. Actually, that's not the best way of saying this. Let's say this is air, and then water is down here. And let's say the light is actually traveling from the water and going into the air like that. Now it's hitting with a certain angle from the normal, the water-air interface, with an angle of incidence I. And then, of course, what we would expect to happen is that it is going to refract, right, as it travels from the water into the air, right, like this. And notice that I tried to draw this such that the angle of refraction is a little bit greater than the angle of incidence here, right? Because in this case, remember that water has an N of around like 1.33, and then air has an index of refraction of around 1. So it's going from a higher index of refraction to a lower index of refraction. And according to Snell's law, which is N1 sine of theta 1 is equal to N2 sine of theta 2, if you're going from a high N to a low N, right, then the angle of incidence, right, has to be less than the angle of refraction if you're going from a high N to a low N. Now, vice versa is also true. If you're going from a low N to a high N, then the angle of incidence has to be greater than the index of refraction. But here you're going from high to low, right? Now, what if, though, the angle of incidence was made to be equal to a number such that if you plug all the numbers into this equation and you solve for the angle of refraction, the angle of refraction is equal to 90, right? In that case, what you would expect to happen is the light ray would refract like this along the interface, but that doesn't actually happen, right? Instead, what happens is that at that angle of incidence, which is also referred to as the critical angle, right? At that point and at any angle greater than that critical angle, right, there will be, instead of refraction, all of the light will reflect inward, okay? And that is total internal reflection, and it only happens when light travels from a higher index of refraction to a lower index of refraction. So B is the correct answer. It doesn't happen the other way around.